Hello and welcome, everyone. My name is Dane Menke. I'm the Digital Marketing Manager here at REGENESIS and Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will provide an introduction to MonoShield, a new chemically resistant preemptive vapor barrier from Land Science. With that, I'd like to introduce our presenters for today. We are pleased to have with us Tom Szocinksi, Director of Vapor Intrusion at Land Science. Mr. Szocinksi is a nationally recognized vapor intrusion expert with over 17 years experience as an environmental scientist, focusing on vapor intrusion assessment and mitigation, remediation, site assessment, and brownfield site management. He has served on both state and federal regulatory vapor intrusion review boards, assisting with the development of vapor intrusion and mitigation guidance, regulations, and exposure criteria. We're also pleased to have with us today Dr. Kristen Thoreson, Director of Research and Development at REGENESIS and Land Science. She will be discussing the chemical resistance testing of MonoShield. Dr. Thoreson heads the Chemical Research and Product Development Program at REGENESIS and Land Science. Her team is focused on developing advanced technologies for the treatment of recalcitrant compounds in mixed environmental media. All right, that concludes our introduction. So now I'll hand things over to Tom to get us started.
Thank you, Dane. First off, it's a pleasure to be able to give this webinar to you guys. And we're looking forward to the MonoShield innovative new vapor intrusion barrier technology that we get to share with you today. We're going to go through a quick presentation agenda, and so highlighting the innovative vapor intrusion mitigation approach. First, I'm going to give you a brief overview of Land Science, and then get into the details of MonoShield as far as target sites, the competitive differentiation, and more importantly, even the chemical resistance testing. I'll follow that up with already some success stories that we have on brownfield case studies. And then we'll finalize this webinar with some open time for questions and answers, 4 sessions related to vapor intrusion mitigation and vapor intrusion barriers. So with the overview of Land Science, we are a division of REGENESIS, and we are a premier vapor intrusion mitigation provider with many solutions. We also provide design assistance, and with a team of engineers and scientists that rigorously work in the vapor intrusion world on a daily basis. We have a certified applicator network for each of our products that we offer. And with that certified applicator concept comes through with a rigorous training that we put our applicators through so they understand the process as we install these vapor barriers to make sure they meet the required necessities that we have detailed for each of our products. We are also an industry-leading vapor. We also offer an industry-leading vapor barrier warranty options for the many suits of the options that we offer for our barriers. So getting into a bit of the detail of MonoShield and why you're all here to listen in today. So we provided a new opportunity for vapor intrusion barriers, and MonoShield was specifically designed for brownfield sites. So we are an innovative company, and at this point we saw that there was a proven market need for preemptive vapor intrusion mitigation at what might be called or characterized as possibly a low-risk site. And low risk could be a relative term, but what we're looking at there is low-level contaminants, radon, methane, or sometimes at sites where there's states that there's not a regulatory requirement for vapor intrusion mitigation, or maybe even not even vapor intrusion guidances. We also have looked at the aspect of large warehouse developments. And this market had been traditionally served with thin mill plastic sheets that were designed more importantly for water and moisture barrier protection, and not really a contaminant vapor barrier. These systems, they're not chemically resistant and are constructed typically with a tape seam. And these tape seams tend to be where some of the weaker aspects are. The other thing that we noticed is in the industry, as we continue to try to come out with a new innovative product for this niche, was the HDP welded, and that's those 60 mil HDP barriers that come out as a welded system. Successful on these large warehouses, yes, but still cumbersome in the time frame of installation. And as I mentioned, for methane or radon only sites is just another component and market aspect that we believe MonoShield is going to definitely target. And as you see here at the last bullet, it's not appropriate for all sites. So MonoShield is been designed for preemptive mitigation. When we have these low-level contaminants, methane, radon, low-level VI risks, and some areas where states or local regulatory requirements aren't necessary. And one would wonder, well, where are we at in 2019? So you can look here across the states, and this is as of literally last week. So there's the red states are states that not only have a vapor intrusion guidance, but they have vapor intrusion guidance that actually detail mitigation information. The green states that are now having guidances that at least have some sort of vapor intrusion, but you can still see quite a few states out there that are gray, and those don't have vapor intrusion guidances. Some states do reference the federal guidance, the US EPA. Some of them even reference the ITRC, but they don't have their own internal guidance. Why is that important? Well, as we're looking through these situations, if you're working on a site in a state that doesn't have vapor intrusion guidance, then you could be dealing with a cluster of different options of what people are proposing, if they're even proposing anything. So, it is important to look through this and understand if there is a vapor intrusion mitigation guidance, what is the state referencing? If you aren't familiar with our website, you can go to our website. We do have links to each of these states. And if there is a guidance or a mitigation guidance, it's there. So the importance is here's where a limitation could be for MonoShield. Some states are going to require a thicker barrier, a 60 mil, thousandths of an inch. So you're going to want to know that as you move forward. So that's kind of why we put that bullet in there, that it may not be for all sites. So now let's get a little bit into the weeds. MonoShield is a composite system. We make note here that it's up to 30 to 40% faster installation than a heat or HDP heat welded, as I mentioned. Where the speed comes is how we're seaming this barrier together. It rolls out, and then it is seamed together with a spray applied a nitrile core, and we'll get into that detail quite a bit in a little bit. But you can also see why we're referencing it as MonoShield. You're going to see there in the right, you're going to see a metallized film layer. This is an innovative concept that we've worked through with our research development team to identify a higher chemically resistant barrier at a thinner concept. So out was born MonoShield, and now we have the metallized film, and it's one layer that really increases that chemical resistant aspect. And as you'll see here, it has a geotextile bottom, so that the base, that geotextile is important so that it can lay across the aggregate and not have concerns of punctures or issues. Even though we do have a high level of puncture resistance in the PET, which is the top, and the metallized film, we wanted to have even further constructability and control over that barrier as it's going to be laid out across quite a few different types of aggregate. It's easy to install. The advanced composite sheet incorporates continuous layers that include the aluminum, as I referenced, and it's a tear-resistant and standalone barrier. So with that being said, as a preemptive measure, you can lay this barrier out, spray the seams, and you've got yourself a preemptive vapor intrusion barrier. So as I mentioned, and we'll get more into the detail, the chemical resistance is not only in the metallized film, but some of the weaker points in vapor barriers are the seams, are the penetrations, and the perimeter. So we have then created a new spray applied nitrile core to address this in the seams, in the penetrations, and perimeters. So coming down just a little bit further, you're going to see the same diagram to the right, but I wanted to get into that a little bit more on the metallized film. So you're going to see here that metallized film, it's encompassing across the entire base layer, with the exception that the only differences at the end of each of the layers, there are going to be no geotextile, and that's done strategically. So as we do these seams, we get a seamless transition as we spray the core across. It is a very flexible product, even at 30 mils, and that's the total thickness composite of the geomembrane, adding the geotextile, the metallized film, and the PET. So the 30 mil gives you that durability, but also it's still very flexible and durable to be able to bend and move as you need to. You're going to see there that we reference the metallized film that's bonded, and that's important. So even if you see in the right picture, there's a series of layers. I don't want you to walk away from this thinking that it's just coming across that way when you have the product in hand. It's one sheet. So it is thermally bonded to create one sheet as a whole when it comes to the site. So the MonoShield, versus thin mill plastic sheets, it's significantly different. And you'll see there, the right picture, you're seeing the tape, and the left picture, seeing how they're spraying that seam. We'll get into it in a little while as far as how those seams go, and we've got some detail to show you. But you can see we're going to offer, and we do offer, that you're allowed to smoke test this. That's important. There are actually some state guidances out there that will require that or highly recommend. Smoke test is important because you find your weakest link. So when you put a smoke, and the smoke test is literally pumping the smoke underneath the barrier, and you're looking for smoke to come through the seams, the penetrations, or the perimeter. And if there is any imperfection in the base layer itself. As I said, it's a fast application, 30 to 40% faster, and you're getting the significant value of that sprayed seam. We do have a certified applicator network, as I touched base when we was introducing land science, and that's important to understand that the certified applicators know the process of how it needs to be installed. And we work intimately with our certified applicators on a case-by-case basis to verify that they understand the process, because each site could be a little bit different. So, and then, as I reference here, is the high seam integrity. One of the weakest concepts of a barrier is if that seam fails. And, we'll walk you through in a little while as far as the information of how those seams go. But what's important is to understand that we work to create this spray applied seam so that we have a seamless type system. So before I get into the details of the construction, I want to kind of appease some of this information as far as the chemical resistance. And I'm going to turn this over to Dr. Kristen Thoreson in the coming slides so she can go through some of our chemical resistant testings that we've been conducted.
Great, thanks, Tom. And so, as has already been mentioned, MonoShield has been designed to be durable and be very easy to install. And those features were certainly key as we produced this or developed this product. However, I'd like to take a moment and just describe some of the chemical resistance testing that we conducted as we developed MonoShield as a means to ensure that the system would adequately reduce the VI risk that we're trying to address. So to accomplish this, our land science R&D team tested a variety of materials as we got our way to MonoShield and the actual material we are using today. And we used a specialized testing chamber that you see on the screen here. To briefly describe the setup, there are two chambers separated only in the middle by the barrier that we're testing. So we can put MonoShield, the mono base in that material or other materials to compare it against you. And the bottom chamber is where we can add a solution of contaminated water. This could be benzene, really any contaminant that we're interested in testing. The contaminant is then volatilized to create the challenge contaminant vapor. And then the top chamber you can really think of as the indoor air. So that's the area that we're going to measure and really be able to evaluate the performance of these barriers, how much contaminated vapors are coming through. And so throughout these studies, we sampled the bottom chamber to ensure that the challenge concentration remains constant throughout the study, and also in between tests, so that every barrier has the same challenge concentration no matter when we're testing it. And then we take the samples from the top sample port. And again, that's where we really evaluate how much vapor has diffused through the barriers. We typically set these up with pretty high challenge concentrations. That allows us to screen these a little bit faster. But we do let them equilibrate for a few days, and then we can compare those relative performance of the different materials. And so the results of this test confirm that the reinforced aluminum-based geomembrane of MonoShield does provide very good chemical resistance. If you want to go back, actually, one quick slide there. Thank you. The results that we have from this, when we looked and compared it to some of the other polyolefin type barriers that are out there, we saw actually a 10 times better performance with the mono base, this aluminum-based material. And so the data I have shown there, again, is normalized. So these values are relative to each other. But what you're actually seeing is that the mono base has a 1/10 of the vapors coming through that barrier than what the HDPE system is. And so that's how we're showing that we really do have improved chemical resistance. And so this internal method has been great. And again, it's a good screening tool for us and gives us a good understanding of the performance. But we've also enlisted a third-party lab to measure the diffusion coefficient for benzene to further validate our measurements and understand the chemical resistance. So the preliminary value of that benzene diffusion coefficient is shown. And I do say it's preliminary because the test is actually still going on. It's been going on for a few months, and we're still collecting data. So that value will be refined a little bit more. However, the order of magnitude is already telling us that this barrier will sufficiently be able to reduce the VI risk as for the type of sites, these low risk vapor sites that Tom described, where MonoShield is designed to be used for. Okay. And then finally, very briefly, I just want to point out that we've also used the same internal testing procedure to evaluate the other component of MonoShield, which is the monocore. That's the spray applied asphalt that Tom described and is used to spray around the seams and penetrations, and really is key to having a complete barrier that doesn't have any leaks for those vapors to come through. And again, in an effort to have a robust chemically resistant system, we actually worked to modify the formula of the asphalt, and we use a nitrile polymer in the asphalt. So just like we go to the lab and we choose nitrile gloves in the lab to provide more protection, the same idea is here. So we added that nitrile polymer, and we found that the testing of the monocore is about 10 times more chemically resistant than other types of spray applied asphalts that are out there. So in combination, this testing of both of the components of MonoShield, both the monocore and the monobase, has allowed us to really demonstrate that the MonoShield system does have very good chemical resistance in addition to that ease of installation and durability that Tom already described. So with that, I'll send it back over to Tom, and he will get into some of these construction details.
Great, thank you. So, we're going to transition here now to the MonoShield construction, as I kind of gave the tickler for a little while that we're going to get into showing these seams and a little more of the detail of it. You can see here, this is just a quick picture of the actual product going down and the seams being sprayed. So the mono base, as I said, it's seamed and it's with a 6-inch overlap and bonded using the monocore that Kristen just outlined at a 60 mil spray. So what that means, and you'll see a detailed diagram coming up, but what that means is that they're spraying 60 mils, laying out the mono base over the top of that at a 6-inch overlap. Then on top of that overlap, there's another 30 mil of monocore being sprayed over the top of that, creating that seamless effect. Mono base is overlapped a minimum of 3 inches at the perimeter foundations with the monocore for the adherence. So again, limiting having to use any type of taping, any type of other adherence, using just this monocore that, as you just heard, has been tested to be chemically resistant against these low-level contaminants. All the penetrations are wrapped using the monobase, and then they're zip tied, and the monocore is sprayed to seal each penetration. And as you heard, the nitrile spray applied core is a new product that we're combining as our monocore with the MonoShield. It has improved chemical resistance. So as you heard from in the laboratory, but even think in the medical field, where you'd be hard pressed to find latex gloves, and it's because of the chemical resistance. It's the puncture resistant. And in our world, we can also say that with our monocore, we have no VOCs in this spray applied core because, well, that would be very important. If you're trying to protect from VOCs, you don't want to add them. But in the industries, things continue to evolve, and we thought, what an opportunity to see if we could create a new type of spray applied core that would be even more chemically resistant. And out was born the monocore. Here's a quick animation for you to see, just to give you a visual of kind of how this would be a spray applied. You can see here, there goes down the mono base, and then you're going to see the certified applicator coming through and spraying those seams. Quick diagram to give you the illustration of kind of how that lines out, but anticipate that as you saw him go through there in that animation of spraying that, that's where we get expeditious concept of installing this, because we're spraying, yes, we come back in QA/QC, but we're getting this in a larger concept of installation. I also wanted to point out that MonoShield can be in conclusion or in combination with vapor vent. So it can still be allowed to be having a passive venting system beneath it. And in fact, we highly recommend it as a redundant type system. It gives you that opportunity to have a vent, a relief valve, if you will, beneath these barriers. So if there were any acclimation of vapors. As I mentioned, we're going to get into some of the details. This is a perimeter detail for MonoShield and how you could tie into that perimeter. Some of you may know every perimeter is not the same. So this is one example and what we have internally crafted as a general design. However, what we pride ourselves to work with our team on is we are design assistants, and we can help go through this. If you're looking at considering MonoShield, we highly encourage you get in touch with our land science team. We work together with you, looking through any of the diagrams that already do exist in the construction world, and we identify what would be the best perimeter termination. In this example, you'll see on step 1 where the monocore is sprayed and the mono base is brought up on a 6-inch overlap. If you heard me earlier, it was a minimum of 3 inches. So in this one here, we're doing 6 because we have the opportunity to do the 6. The larger the seam that we can tie to the perimeter, the better. But then step 2 is important and imperative as we sandwich that base layer around with the core, creating a seam that will not have any type of leak. But again, as I said earlier, one of the weakest concepts of the barriers are the seams, the perimeters, and the terminations. So the termination is still going to be smoke test to confirm, even if you have the step 2 complete, that you have an airtight type barrier. This is just a quick diagram to show you visually the seam overlap. So the seam overlap is what I just showed you with the animation, also what I showed you in some of those pictures. It's a monocore at 60 mil, then the next base layer is brought over the top at a 6-inch minimum overlap, and then the monocore is then sprayed over the top of that, sandwiching it together. Then again, once we visually have completed that, then we can go through and do the smoke testing of the area to confirm that it is airtight. So I want to hit home, and you can see on the right, there's some pictures of the smoke test of the MonoShield. We have our certified applicator network, and it's imperative to have that so they understand the importance of our details of how it should be installed. They've been trained and understand the process. So how do we control that certified applicator network? Well, we work through them so that they're the ones that can purchase our MonoShield, and they're going to understand how to put it in. So if some other construction company wants to come in and buy our MonoShield, they would have to work through our certified applicators to make sure that we have visual on all these barriers that are going to be installed, just as similar to our other products. Another bullet here is the inspector training and certification. So that's important, and what that is, if you're not familiar, our certified inspector training is actually done online, and you will go through the training process to understand what to look for when you're on site to verify that the barrier has been installed. We do encourage that and or require it based on the type of warranty offered. With MonoShield, there are limited warranties. So the more important thing with the MonoShield would be that the inspectors are there to visually verify that the barrier is being installed and smoke tested correctly. And then an inspection report can be prepared and then submitted to us for documentation. As I put here, the bullet point is smoke testing. Where we've designed the MonoShield is to be in the market of these preemptive mitigation systems and to be in these low-level radon, methane, low-level VOC sites. But it is important to be able to still QA/QC, and with our sprayed seams, we are absolutely on board with requiring and or recommending, depending on the site, for the smoke testing to be conducted. And then the other QA/QC measure is the visual inspection itself, just to verify as it's completed. And we highly encourage that if the inspectors are on site, that they even take video or digital photographs of these installations. And if you are interested after this webinar to be a certified inspector, it is free. you can feel free to reach out to any of us at Land Science and or REGENESIS, and we can set you up with that online training. It's just a porthole that you'll get a login password to get into. And then once you've completed that, we will send you a certification card. And where that can be important is as you're inspecting these, we may need a third-party inspector, and we can then call in on you guys as we pull up our list, and we keep a list of our certified inspectors. As I said, MonoShield does have warranties. Land Science offers a limited warranty if you're familiar with some of our other warranties on our other products. But we do offer our warranty, and we stand behind that because it's a necessity when we're dealing with these preemptive sites. So we offer a 1-year material and a 5-year material warranty. So that's the overview of MonoShield. We've already had the liberty of having the opportunity to have great success on a couple sites already with MonoShield. And I wanted to kind of walk you through a few case studies. First one is the Liberty Park Brownfield, and the ghosted picture in the back is the actual building. It's almost a 600,000 square foot building in Southeast Michigan. Some of the highlights, it was a competitive tax increment finance plan from the state of Michigan. So the state of Michigan got involved quite early on this project, as well as the city of Sterling Heights. It made this brownfield redevelopment possible. Liberty Park is being transformed currently into a property that's going to bring many jobs and growth to this community. If you're not familiar with the Sterling Heights area, it's what they referenced as Automotive Alley. And as the Motor City continued to evolve, they had to spread their wings in the urban areas, and they went up into the Sterling Heights and created a series of automotive manufacturing. A lot of those have gone away, but the opportunity here was that now these sites sit quite blighted, but now with the brownfield re-incentivizing programs, they're having the opportunity to redevelop them. So MonoShield merges the benefit of both rollout barriers and a spray applied barrier for the site. And this was important on this site since the size of it, we were talking close to 600,000 square feet. It was important to understand we needed a fast barrier, but an appropriate barrier based on the contaminants that were at the site. Here's the background as I gave you. The Liberty Park is located in Sterling Heights, 23 miles north of downtown, as that automotive alley as I referenced. In the last 5 years, the region has experienced an intense growing demand for the warehouse and high-end office space. The site is a landfill-based brownfield. So, as you can see there, they had incinerator waste, which led to site contamination in the 40s and 50s. Liberty Park posed multiple remediation challenges, including a variety of known contaminants, and low-level contaminants, I must add. But they also, because it was a former landfill, we had load-bearing issues at the site as well, so geotechnical concerns. Ashley Capital was the leading developer here, and leading commercial real estate investment company saw the potential for the Liberty Park site to bring jobs and economic growth to the community, as well as meet the increasing demand. So Ashley Capital is a leading commercial real estate developer across the nation. So the opportunity here is the redevelopment was made possible due to the tax increment financing, working with the city and the state. And MonoShield was chosen for vapor intrusion due to its cost effectiveness, the reliability when compared to the traditional mitigation systems that they were considering, tape type systems. MonoShield, it was fast and easy to install. And at this site, it got to almost a 45,000 square foot per day installation. So if you're not familiar, that's pretty significantly installation speed. The durability, we have, as I've touched base already on the MonoShield, the aluminum nitro modified system was designed to withstand that tough conditions. And if you're familiar with these large type of warehouse installations, one of the key concepts of these floors is it's a large concrete pour. And if they cannot have the durability of a barrier beneath as they're trying to pour in all this concrete, they start having to increase costs significantly with pumper trucks and whatnot. And they were able to alleviate that working through with the MonoShield. Here's a quick timeline for you. So you can see here, 40s and 50s, it was an incinerator waste landfill. And we're looking into the recreational complex being opened. And then Liberty Park closed and purchased by Ashley Capital in 2017. Construction beginning, the MonoShield being installed literally last month. And it is the full development is scheduled to be completed in August of 2019. Here's that picture again. As you'll see, these are the gentlemen here inside of the Liberty Park, our certified applicators, and they're spraying the mono core onto the mono base. So as I briefly touched base on, there was multiple challenges on this site. One of them being that it was built on a landfill. So Oliver Hatcher was the general contractor, and they had to work through and install these 8,000 geo piers, which increased the allowability to bear the pressure of the limit of the foundation settlement, because on a landfill, you do have significant settlements. So that was the first challenge, was building on top of an unstable landfill. And the second was, two key challenges at the Liberty Park required innovative design solutions. It was the cost associated with long distance concrete pumping, as I already mentioned. So they were able to put in an 8-inch layer of stone placed on top of the MonoShield, followed by the building slab. And hence why I was getting to you that important concept that MonoShield is durable. They were able to put an 8-inch layer of stone over the top of MonoShield, so they didn't have to have this long distance concrete pumping, which in turn gave a cost benefit by avoiding that extra cost of pumping concrete over a very large area. A quick little quote. This is from Ashley Capital's VP of Construction. His reference here is the MonoShield system was the most cost-effective system in the market, and that he'd been able to shave off a couple months in the construction by going with this. And that was due to the concrete that we just referenced, the overall approval process with the state. There's a whole mechanisms that bring into why it expedited it a few months, but that was a key concept for Ashley Capital, to be able to increase the expeditious concept of putting in the vapor barrier in construction. Another quote quickly is Mark Quimby is a senior project scientist, senior consultant for SME out of Southeast Michigan. And here's a quote, you can read it. He's been looking for a product that meets the efficacy of the rollout barrier and the spray applied components. We can mimic that comment and quote from a lot of different folks. We've heard this for a while, and hence why we, as our team, as innovative as we tried to create this new barrier, and we are excited to have this launched out here and released to you guys. The next one I'm going to get into is Hazel Park Brownfield, another Southeast Michigan and another Southeast Michigan site. And as you can see here in the background, you see a picture of a horse. Well, you'll see in the coming slides, it was a former horse racetrack. So they're in Star there is where it's located, just outside of Detroit. There were several organizations, including the city of Hazel Park and the state of Michigan, again, offering the support to redevelop this Hazel Park Raceway. Again, the tax incentive for the state in the form of the Brownfield Redevelopment Act. And MonoShield was chosen for this project after the successful application of the nearby Liberty Park site. This building is over 600,000 square feet and is a part of a series of large warehouses that are being installed at the Hazel Park Raceway. The project was assured of staying on time and on budget due to the reliability and the cost effectiveness of MonoShield. So as I said, in the 1940s, this property, before it was the Hazel Park Raceway, was actually another landfill for incinerator waste. So it resulted in the presenting of low-level contaminants and methane at the site. So the Hazel Park Raceway was opened in 1949, and at one point represented 1/3 of the city's revenue. Due to the demographic and financial changes, the park was officially closed in 2018 to make way for the new warehouse spaces. In 2015, the first portion of the Raceway was sold to Ashley Capital, and this resulted in a new industrial and manufacturing space known now as the Tri-County Commerce Center. And in 2018, Ashley Capital purchased the rest of the Raceway Parkway, and construction of the Tri-County Commerce Center number 2 went underway. So the quick overview, Hazel Park Raceway is located in a designated opportunity zone, key words that are kind of going around our industry now, which was also established by the U.S. Federal Treasury to encourage businesses to invest in blighted properties by providing further tax incentives. SME recommended a modified Geo Seal vapor intrusion barrier due to the presence of on-site hazardous vapors in building number 1. And in building number 2, we utilize the cost-effective reliability of the MonoShield as a new innovative barrier for this second building. SME chose to install the MonoShield because of the new technology and provided the best chemical resistance for the Brownfield site at building number 2 and based on the success of the Liberty Park. Here's a quick timeline again for you. 1949, the Hazel Park Raceway opens. 2015, the first building. 2017, and 2018, you're looking at building number 2. And in June 2019, of the installation of MonoShield. Anticipated completion of the entire building by fall of 2019. So the results of both those, and I wanted to share, is it's a success story of an innovative barrier and being able to be part of a brownfield solution. We worked with the regulatory community with the state of Michigan provided all the testing that you heard from Dr. Thoreson earlier with the state of Michigan to show the information as it was related, and working with the local community, City of Sterling Heights and City of Hazel Park, working with the local engineers and working with the general contractors, and more importantly, and just as importantly, the developers, Ashley Capital. So Liberty Park and Tri-County Commercial Commerce Building preemptively protected now for the vapor intrusion, and they can have that box checked. Completed in late summer of 2019 to early fall, both of these developments are going to bring significant job and economic growth to the already booming eastern and southeast Michigan. All the stakeholders involved in this are pleased with the results. So we're going to stop here, and when ready to help you find the right solution for your site, we encourage that hopefully this was a valuable information to learn about MonoShield, but more importantly, understanding that Land Science is here to provide design assistance, vapor intrusion evaluations. We're here to be able to find the right solution for your site. And with that, I'm going to turn it over to having the questions be opened.
All right, thank you, Tom. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast, as Tom said. Before we do this, just a few reminders. First, you'll receive a follow-up email with a brief survey. We really appreciate your feedback, so please do take a minute to let us know how we did. Also, after the webinar, you'll receive a link to the recording as soon as it is available. All right, so let's circle back to the questions here. First question is, do you still need a moisture barrier if you install MonoShield?
That's a great question. So if MonoShield is being specified on these building structures, you would not need a moisture barrier if it's not a hydrostatic condition. If we're dealing with hydrostatic conditions, that would have to be a self-evaluation, a site evaluation that we need to work with the developer and or the consultant on. But if the construction diagram detailed a moisture barrier, as I indicated earlier, this is in lieu of that, so you can bypass the tape type moisture systems, and this would act as your moisture barrier as well.
All right, great. Lots of additional questions here coming in. Let's see, this one is, how do you install a MonoShield on vertical surfaces? If it cannot be installed, what is the procedure for vertical wall mitigation?
That's a great question. So MonoShield is designed for horizontal installation. However, on a site-specific basis, we'd be willing to work through with the consultant to identify if there is a site-specific identification of how we can use the core to adhere that to the type of vertical application that would be necessary. But again, a broad response of saying it can or can't, it's too hard to answer that. It'd have to be a site-specific.
All right. Okay, so next question here is, will MonoShield stick to the concrete after installation?
So MonoShield as a full composite barrier, as I said, is part of the monocore. The monocore will stick to concrete, and that is the adherence concept around to the perimeter, to foundations, to footers. The base layer itself is just that, a base. It does not have any adherence concept, but the monocore is what gives the opportunity to have the sticking, if you will, to the concrete. And it does have a curing process of within 48 hours, it'll be completely cured.
Okay, great. So next question here is regarding regulators, the regulatory community. Are regulators accepting of MonoShield?
So yes, as I heard at the end of my discussion there of one of the case studies, the state of Michigan was specific of one of accepting the use of MonoShield at those two sites we gave as a success story. But we are having positive responses on many state regulatory response as far as where MonoShield fits the niche. As I said, it's not for every site, so the regulatory community is understanding that the limitations will be that it has to be low-level contaminated sites. It's radons, it's the methane sites. If it needs to be above and beyond that, thicker barrier, then that's when you look at the other type of barrier solutions that we offer.
Okay, all right, so next question is like a two-part question. It is, can MonoShield be used to wrap concrete utility vaults that are buried in subsurface soils? And then also, can it be in direct contact with contaminated soil and groundwater?
All right, first question. It is not designed to wrap utility corridors impacted within soils. With that being said, if those are the situations you're running into, I encourage you to contact our land science team, because there might be a type of solution we could create for that situation. And could you repeat the second question again?
The second part was, can it be in direct contact with contaminated soil and groundwater?
The initial answer of can it be in direct contact of contaminated groundwater or soil? Yes. But again, that's a relative answer, because we need to understand what type of concentration we're dealing with. And at that point, we need to evaluate on a site specific again. So we would encourage that the data be shared with us so we could then thumbs up or thumbs down if it can be. It would have limitation if we're dealing with significant DNAPL or LNAPL type situations. However, again, we need to be able to look at the data to be able to confirm, but it can be placed in direct contact of soil contamination and groundwater contamination.
Okay, great. So let's see here. Next question is regarding utility pipes. It is, can you describe how utility penetrations are handled, including multiple pipe penetrations? How easy is it to cut to work around the utility pipes?
Sure, it's a great question. So we do have utility penetration details generally. However, in a perfect world, we would love a utility penetration sits all by itself. But obviously, as many of you probably are aware, they're clustered together. Why it's even more important how we have the success of using our mono core, it can be sprayed after each one is zip tied. So it is easy to cut. Can cut with an X-Acto knife. You then bring it up through and wrap it up to the utility penetration, and then zip tie each utility. So that zip tie will create that bond and tightness to the utility. And then the most important concept is coming back in with that spray core. So the monocore is then sprayed across that whole junction of the utilities. And then to confirm you have an airtight seal in those utilities, the smoke test is conducted in those clusters to verify that you have an airtight barrier at that seam or at the penetration.
Okay, so next question here is, how easy is it to work with, or would it be to work with in an apartment building renovation with many walls and asymmetric floor footprints?
MonoShield would be very easy to be worked through on tons of different types of foundations, whether it's a waffle slab, whether it's footers, significant footers, whether you're dealing with separated footing joints. It's an easy barrier to manipulate. It's an easy barrier to get to bond to the concrete. And even if you have a significant amount of penetrations from utilities and or whatever the construction aspect, whether it's grounding rods, whatever you're dealing with, it can be easily treated through pretty much any type of development.
Okay, and somewhat related to that is a question on cost. They're asking the approximate cost per square foot for a simple warehouse install versus a more complicated apartment building with, say, 4 to 6 units per building.
Great question. So a general ballpark that we would be seeing for an installation, similar to like I just gave as an example of those 2 case studies, installation price would be at around $1.40 to maybe even $1.30. Installed price. Now that's the simple open wide warehouse. Now if you're dealing with a complex site where it's a multi-unit, multi-residential, multi-complex, we could be into the low 2s. But it would get, again, general ballpark, and we would definitely encourage as you consider using MonoShield that you get a hold of us, 1, to see if it is an applicable barrier, and 2, so we can give more specific than less on the ballpark prices.
Okay, great. So next question is MonoShield exclusive to REGENESIS and Land Science nationally, or are there other distributors participating?
Great question. MonoShield is exclusive to Land Science and REGENESIS. It is our patented product. And as I said, we to hold it close to our chest, we also have a certified applicator network. That is who we will be selling the product to, so that it is not being distributed without, 1, our knowledge, and without our oversight and understanding.
All right. So next question here, I think you may have gotten into this, but asking a question about comparing MonoShield to thin mill plastic. How does this compare?
Well, as I kind of had the one slide earlier showing the check marks, yes and no's, it's 30 mils, so that's thousandths of an inch. And a lot of these thin mill systems are not that thick. They're 10, 15, 20, so a little bit thinner. They are a single layered system, so they do not have the geotextile. They don't have the geotextile fabric, and they also don't have that metallized film infused into it. But again, the most important, even above that, and not saying the metallized isn't important, but the spray seam, these other tape systems are valuing that the adherence of the tape will hold against any vapor intrusion. And we have tested our core to show that we have a chemical resistance. These taped type systems, the tape is not, does not provide that chemical resistance.
Okay, all right, so next question is, what is the difference between MonoShield and Geo Seal?
Well, there's a significant difference. Geo Seal, if you are familiar, is one of our barriers, is a three component barrier. So they have the base layer, which is an HDPE geotextile fabric down, when then there's a 60 mil asphalt latex core, and then the Geo Seal bond. So that is a sandwich type barrier. It provides the solutions for these heavier contaminated sites, and it is designed to provide that solution. The MonoShield is, again, a preemptive barrier that is out there to answer some of these sites that needed something, but maybe not everything.
All right, great. So the next question here is, this person wants a little bit of, I guess, clarification. He's saying the takeaway is that MonoShield is appropriate more for methane and radon, but not for VOCs such as chlorinated solvents and petroleum hydrocarbons.
We are marketing this because of our design and how where it is the barrier can deal with low-level VOCs. However, granted, that's a very relative term. This is all to further encourage that we work with them as not only a design assistance, but a VI evaluation. And we have no problem turning away and saying this is not an appropriate barrier for that site. However, to say generally it's not okay for chlorinated sites, or it's not okay for benzene or petroleum sites, we wouldn't generally say that. It is designed, and that bullet, the person who had made this question is absolutely right. We're looking at methane and radon sites. However, low-level contaminated sites could be evaluated on a case-by-case basis and approved appropriately, as hence why we have the chemical resistance testing to show why we tested it against benzene.
All right. Okay, great. So the next question is regarding the case studies. In the Michigan examples, were passive vapor mitigation systems required with the MonoShield?
Passive systems were installed in each of these buildings and designed in a way that they could be active. In the state of Michigan, that is built right into their guidance that they highly recommend. And on these, because the state was handling the Brownfield, it was required to have a redundant type system, and including the passive venting system along with the barrier.
Okay, so next question is, can you maintain continuous insulation at the foundation with a MonoShield installation?
So this must be from somebody from the Northeast or Midwest who deals with these foam boards. I understand the question. And you have to have a perimeter termination to have a full envelope of encapsulation to make sure you have an airtight seal. So with that being said, we have design assistance that we've worked through this already in previous barriers that we've released, that we have this situation, and we can have a floating foam board if necessary over the top of that perimeter termination and still creating that success of having an insulation. Yes, there's a gap, and yes, it's not continuous, because if you have a continuous foam board going all the way up, you cannot then terminate that barrier to the perimeter. So we do have a solution, though, that we work through that in the colder states and colder countries.
Okay, great. So next question here is, can this be applied to an existing vapor mitigation system as a second barrier?
Yeah, this could be applied as a secondary barrier. It could be looked at as far as putting on top of something, or it all would have to depend on the site. If, let's say, if it was a crawl space that this mitigation system was installed, we could possibly have our certified applicators come in and install it that way. If they're going to be removing the concrete, and then we could put in again, or if they were allowing us to put it down and put another layer of concrete. It's not meant to be a exposed type barrier, though. So if it has to have elongated foot traffic over the top of it, that is not the mechanism here. It is meant to be a sub-slab barrier.
Okay, great. So next question is, what was the installed cost at the Liberty Park site?
The installed park at the Liberty Park, the installed cost at the Liberty Park was between 130 and 140 per square foot installed.
All right. So next question here is what temperature can this be installed in?
Down to 45 degrees is with the core material. If it's colder than that, we can work together, and there's different solutions that we can do as far as the core itself, as far as possibly tenting. There are opportunities for that, but we typically say 40 to 45 degrees, and that's just the core. The base layer itself, obviously, is just the base layer, can be laid out. So we can work through a strategic plan of how to install this in a colder season in the colder areas of the region.
Okay, so a couple more. So there's lots of questions about the contaminants, and this next one is this barrier system applicable for petroleum hydrocarbon vapor intrusion such as LNAPL, which may vary in product form from aviation, gasoline, fuel oil, etc.?
As I somewhat answered in the previous question about the contaminants, it would have to be a site-specific evaluation. If we're dealing with LNAPL levels, there's a good chance we're going to recommend a more robust barrier. Again, it would have to see as far as horizontal distance of the contaminant plume, if it was a migrational concept, if the type of soils that are there, because if it's an LNAPL and it's 17 feet down and it's there's a clay aquitard above it, well, then maybe we already still could. So, but in general, if you're dealing with LNAPL and you know it's causing a potential concern to the building, there's a good chance that we're going to recommend our more robust barriers at those sites.
Okay, let's see. Another question here regarding the contaminants is how low do the VOCs and SPOC concentrations have to be for MonoShield? Same order of magnitude as ESLs or 10 times ESLs, as the examples this person gives?
So if you are familiar, you can go take a drive from California into Nevada and have different ESLs. The screen levels are going to differentiate between the states. So it's too hard to give a broad answer of saying what levels they're going to be. However, what we would like to do is just work with, if you have low-level contaminated sites and you're considering the MonoShield, as a team, we would look through that to compare it to the regulatory requirements, compare basically where we're at. But as you saw what Dr. Thoreson provided, we do have significant chemical resistance in the fusivity of benzene, which is one of the main culprits. As you know, BTEX is specifically benzene and xylenes are the ones that try to break through, and benzene's showing that it's not going to be breaking through at a readily level. So again, I know that's I'm not trying to sidestep a direct answer, but it's too hard to give a direct answer of giving a number to be able to always reference. It needs to be an evaluation on the region, on the state, on the site itself.
All right, well, thank you very much, Tom. That's going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you would like to learn more about vapor mitigation technologies from Land Science, please visit landsciencetech.com. Thanks again to Tom Szocinski and Dr. Kristen Thoreson, and thanks to everyone who could join us. Have a great day.